So I'm back here with my friend Menas Kafatos. We're in South Korea on a tour, and we're just hanging out talking about the big mysteries of life and the universe. And our second conversation is about the fine tuning of the universe. We said in our first video, which was about the source of the universe being nothing, we kind of mentioned that the nothing could have organizing power. So this leads me to a very fundamental question, Menas. The universe is said to be fine-tuned with what are called constants. So first of all, can you explain the meaning of the word constant?
The constants in physics, for example, are quantities that so far they don't come out of theory. They are there, like the speed of light or the Planck's constant. But they do play an extremely important role because they guide the physical laws, what we call the physical laws under which the universe operates. Now, the biggest mystery and at the same time embarrassment, I would say, of modern physical science and actually biological science is that we have no way to account for the values of these constants.
Okay, so you said the speed of light is a constant.
The speed of light
There's something called the gravitational constant.
The gravitational constant.
Then there's the ratio of the gravitational to the electromagnetic fields.
Correct.
And there are several others, right?
There's several relationships that you can build. And in fact, ultimately what we want is dimensionless ratios because you don't want a constant to be dependent on specific units. You want to be dimensional. It's pure numbers. So indeed, as you just said, the ratio of the gravitational force, or the other way around, the ratio of the electric force to gravitational force, turns out to be a very very precise and very large number.
I see.
It's 1 followed by 40 zeros.
Okay. Now, these, therefore, constants, as you said, are numbers.
Yeah.
They are relationships of numbers to numbers.
They're relationships of certain physical values to other physical values which give you dimensionless quantities. And we're talking about dimensionless. They are pure numbers.
Okay.
So when I say
they have no dimensions.
They have no dimensions.
And there are, how many constants are there in nature?
Well, it depends what point of view you take in terms of quantum field theory, etc. But in ordinary physics, really, we have a handful of them. We have the gravitational constant, we have the speed of light, the Planck's constant, the fine structure constant, which is a pure number. And when you take a look at them, the basic question that arises is why these values and not something else?
And if they weren't as precise as they were, and if their ratios to each other weren't as precise as they were, or they are, then you and I wouldn't be having this conversation because there would be no universe. Right?
There would not be a universe. It would not be a conscious universe. It would not be an alive universe. No matter how you want to describe it, it would not be the universe that we live in.
Does this is this what is usually called the anthropic principle?
The anthropic principle is related to it. The anthropic principle came out because people noticed. Biologists and physicists noticed that the values that we're talking about, those ratios, again, as we said, if they were slightly different, we would not be here. So the anthropic principle is like an encompassing principle that says, well, they are what they are because the universe not only has to be a physical universe, but it has to take into account the existence of sentient beings, alive beings. Mm-hmm. But if you really think about it, the anthropic principle doesn't really tell you very much. It just tells you in a simplistic way, if you want to put it that way, that we are here because we're here.
So coming back to our point that, the quantum vacuum has organizing power, or the nothing from where the universe emerges has organizing power. The organizing power is actually, in a way, contained in these constants and their relationship to each other. Would it be so?
So there are two choices. You're putting your finger into a very deep question. Two choices. One is that those constants or these ratios of the constants are just purely by chance. They actually, we mentioned the ratio of gravitational force of the electric force, the gravitational force. There is another relationship when you take the radius of the universe to the radius of an elementary particle. It also turns out to be 1 followed by 40 zeros. Now, why would these two numbers be the same? Mm-hmm. They're quite close to each other. One point of view is that it just happens to be that way. Mm-hmm. The other point of view is the self-aware universe, or the self-design. I hesitant to use the word design because it's used by...
Self-created.
But it's self-created. It's self-driven, let's put it that way. It drives itself. And it picks those...
precise numbers.
Out of this huge landscape of possibilities, it picks the right ones that give us the universe with sentient beings and alive beings.
This is what we mean by fine-tuning. If the tuning was slightly off, we wouldn't be here. And the universe wouldn't be here. And
let's talk about that fine-tuning, because actually it boggles the mind. It's actually quite simple, but let's follow the line of thinking. If the sun puts a large amount of radiation in the visible part, mm-hmm. that is determined by the structure of a star like the sun, and the gravitational constant, etc., etc. The atmosphere of the Earth is transparent to the same part of the spectrum. That is determined by the macrophysics, by the molecules, by the fine structure constant that I mentioned before. Now, why would the two be related to each other? Why would the sun put out the radiation that it does in the right part of the spectrum, where the Earth's atmosphere happens, mm-hmm. to be the right atmosphere to allow the radiation to come in and to cause photosynthesis and give power to biological structures and living structures, etc., etc. It's a big mystery. Mm-hmm. You can say, well, it just happens to be that way. But I really don't believe that. That is, the possibilities are so mind-boggling that I think it will be actually quite a strange universe if indeed it was made that way.
The alternative, of course, is that there are 10 to the power of 500 other universes, and this one happens to be just the throw of the dice.
Exactly. So the alternative is it's all pure chance. It comes out of the superstring theories, which is the number that you just mentioned, 10 to the 500. That means that just one out of this 10 to the 500, and that number, by the way, is 1 followed by 500 zeros. It's just a
it would take us eternity to count.
It would, even, here's a number. If you started having a millisecond, mm-hmm. if you created a universe like that every millisecond, mm-hmm. okay? Mm-hmm. Because you want to, and you had an algorithm, a computer that will mm-hmm. check that universe in 1 millisecond, right? Mm-hmm. 1,000th of a second. Mm-hmm. Since the Big Bang, we've only gone through 10 to the power 20 of these universes.
So we would still
have a long way to go.
Billions and billions and billions of years.
Essentially, you have to wait for eternity. Really, eternity.
Okay, so these are the two alternatives. Each of them is mind-boggling, actually. But the first alternative seems more rational, which is suggesting a mind-like universe, a mathematically mind-like universe. That, if there is this source that we call God or whatever the mystery is, don't have to use the word God. It's a kind of a mathematical mind that is very precise and fine-tunes its orchestration to conceive, construct, govern, and ultimately manifest the universe.
Exactly. And if you take that point of view, which you and I favor, then, in a way, actually, it's quite logical and quite scientific. The jump that we have to make, and it's not a big jump, is that, in fact, the universe is self-aware and self-driven.
And mathematically
describable.
And
mathematically describable.
Would you say God is a mathematician?
As
a mathematician, you would like to believe that?
As a mathematical physicist, I would like to believe that. And in fact, the ancient Pythagoreans believe that.
Okay, great. This was a great conversation. Thank you once again.